Pre-statistics. Using systems to model data. Lesson objective. Use substitution or elimination to make predictions about situations described by a table of data. Lesson objective. Example 1. In a previous example, we modeled life expectancies measured in years for W of t and M of t of U.S. women and men, respectively, by the system W of t equals 0.105 t plus 77.53 and M of t equal 0.203 t plus 69.91, where t is the number of years since 1980. We'll see the table on the next slide. Use a symbolic method to predict when the life expectancies of men and women will be equal. So we're going to take W of t and set it equal to M of t. So we're going to solve this system by substitution. So here we have the table. To review how we found the models, the number of years since 1980 is going to be our independent variable. So this will be 0, 5, 10, 15, 20, and 23. This is the dependent variable involving women, and this is the dependent variable when we do men. So let's find the model for women first. So we hit our stat button, then we hit enter. For list 1 we put our independent variable. For list 2 we put in the dependent for females. Then we hit stat, right arrow to calculate, then number 4, linear regression. This pastes the linear regression command in the home screen. We press enter, and here's the regression line, where A is the slope, 0.105, and B is the y-intercept, which is 77.53, rounded off. For men, again, we put in the independent variable in list 1, and in list 2 we put life expectancies for men. Press stat, right arrow, then number 4. And here we see the model for men has a slope of 0.203 and a y-intercept of 69.91, rounded off. So we have our two models. The intersection of the two models represents the time when life expectancies of men and women will be equal. In other words, when W of t equals M of t. Again, we're going to solve this by substitution. We substitute the expression 0.105 t plus 77.53 for M of t and the equation M of t equals 0.203 t plus 69.91, and we solve for t. So basically we are setting the two expressions equal to each other. So here we have the expression for life expectancies for women equal to the life expectancies for men. The next step, since we have t values on both sides of the equal sign, I'm going to subtract 0.203 t to both sides, and then I'm going to subtract 77.53 to both sides. So we combine like terms on the left hand side and on the right hand side. We get negative 0.098 t equals negative 7.62. Now we divide, and we see t is approximately equal to 77.76. We substitute this value in for t, and the equation W of t equal 0.105 t plus 77.53, and we get a value of 85.69, rounded off. So the approximate solution is 77.76, 85.69. So we would say, according to the models, the life expectancies of men and women will be equal to about 78 years plus 1980, which would be 2058. At that time, the average life expectancy for both men and women will be 85.69 years. To verify this by graphing, we put the life expectancies for female in Y1. We put the life expectancies for men in Y2. We hit the window button. We changed the X min to be 0 and the X max to be 150. And this is because the point of intersection for the X is about 77, so 77 is about halfway between 150. We want to count by 10. So for the Y, I picked 60 for the min and 100 for the max, because the Y coordinate of the intersection is somewhere in between these two. You could use different values here. And then I'm counting by 5s for the Y. This is the point of intersection, and we can use the intersect feature to calculate where this is. So we hit second and trace, which is calculate, go down to number 5, select the first line and the second line, and press enter, and here we see the point of intersection is about 77.76, and the Y coordinate is 85.7 approximately. So we have verified the solution by graphing. When will men have a larger life expectancy? We'll write this answer as an inequality. When will women have a larger life expectancy? We'll write this answer as an inequality. So if I hit second and window, which is table set, since we know the point of intersection for the X is 77.76, I'm going to start it at about 77.4. I want the table to count by 0.1s, and that will produce this table. Now using this table, we can see at about 77.7 these are approximately equal, and when we go beyond 77.7, we see that Y1, which is the women, is smaller than Y2, which is the life expectancies for men. So men will have a larger life expectancy when T is more than 77.7 years. Less than 77.7, we see that Y1 is larger than Y2. So we would say when T is less than 77.7 years, women will have a larger life expectancy. Summary. So in the previous example, we used substitution to predict life expectancies. Graphically, this is the intersection point of the graphs of the two life expectancy models. We can find intersection point of the graphs of the two linear models by graphing, substitution, or elimination. Thanks for watching.